Hello guys, welcome back to the YouTube channel. In this video, we're going to discuss arrays problem number 7 in must do coding questions, which is number of pairs. If you are new to the channel, please like and subscribe to the channel and click on the bell icon. So today's problem is number of pairs. So it is a pretty straightforward problem. Number of pairs given two positive integer arrays ARR and BRR. Find the number of pairs such that x power y is greater than y power x. So here we will be having two arrays named ARR and BRR. Let's take this example number 1. ARR consists of 2, 1, 6 and BRR consists of 1 and 5. So here we need to find a pair such that x power y is greater than y power x. So in this case, like, what will be the pairs? The pairs will be 2, 1, 2, 5, 1, 1, 1, 5, 6, 1 and 6, 5. So in this number of pairs, there are only 3 pairs such that x power y is greater than y power x. So like, let's take this pair 2 and 1. So 2 power 1 is greater than 1 power 2. So this is one pair. And 2 and 5 here also. 2 power 5 is greater than 5 power 2. So this is one more pair. And 6 and 1. So this is third pair. So basically, in these two arrays, we need to find a pair x comma y so that x power y is greater than y power x. So what is the expected time complexity? It is big O of m plus n. Yeah. So basically here what we will be getting two arrays. Let's take the two arrays. Let's take this is ARR and this is BRR. And an element in ARR is called, let's take x, and BRR it is y. So now what exactly we need to do? We need to find the pairs. Like, what are the pairs? X comma y is a pair such that x power y is greater than y power x. So this is our final outcome. We need to find a pairs. That's it. So what is the brute force approach to solve the problem? By iterating within the two arrays and every time calculating the x power y and y power x and checking whether it is a greater or not. So basically here when you are iterating, iterating is okay, big of length of array of ARR into length of array of BRR will be the time complexity, and like computation also, like it takes more computation. So whenever the values of the integers in ARR, if it is 30 or 20, so the computation like 30 power 40, so it is very high computation. So that's why that is not recommended. So basically, how to solve this problem? So yeah, in mathematical observation, we can assume one thing, like we can tell one thing, like if y is greater than x, then x power y is greater than y power x. So this is a mathematical observation. So basically, whenever y is greater than x, then obviously x power y is greater than y power x, but with some exceptions. We will see that exceptions after. So let's take an example. Let's take x equal to 3, y equal to 5. So obviously 3 power 5 is greater than 5 power 3. So what is 3 power 5? 3 power 5 is 243. Is greater than 125. Obviously this is correct. So in most of the cases, whenever y is greater than x, x power y is greater than y power x. But there are some exceptions. We will see about that exceptions now. So basically the exceptions comes like in the values of 0 and 1 only. So if we handle the exceptions correctly, we can easily solve the problem. So before that, what exactly is an exception? See, what is our observation, mathematical observation? We have assumed that whenever y is greater than x, then what we can tell? We can tell x power y is greater than y power x. Or else you can tell in one more way. Whenever x power y is greater than y power x, y is greater than x. So this is our mathematical observation. But here, what is an exception? Exception in the sense, even though my y is greater than x, this is false. Like even though if my y is greater than x, x power y is not greater than y power x. Or else one more thing you can tell, my x power y is greater than y power x, but y is not greater than x. So if this is true and this is not true and this is true, this is not true. So that is an exception. So basically the exceptions will be coming in the values of 0 and 1 only mostly. So we will calculate the values 0, 1 with respect to of x and y, and after that the same approach we have followed, right, to calculate the number of pairs. Whenever y is greater than x, obviously x power y is greater than y power x. So in that way we will do. So okay, we will take first exception. There are basically 4 exceptions, that's it, we need to handle. So first exception is whenever x equal to 0. See, whenever x equal to 0, there is no pair forming x comma y, so that x power y is greater than y power x. Why? Because see, whenever x equal to 0, what happens if we substitute x in the formula, x power y is greater than y power x, what happens? 0 power y is greater than y power 0. What this will happen? 0 power anything is 0 is greater than anything power 0 is 1. So no matter what value of y you take, so this can't be true, right? So basically, whenever the x value is 0, one thing you can state, that is 0 pairs are formed. That's it, very simple. So 0 pairs are formed of x comma y, so that x power y is greater than y power x. That's it, very simple, straightforward. So after that we will see the second exception, which is x equal to 1. So whenever x equal to 1, we will be having only one pair. That's it. That one pair is only 1 comma 0. So whenever the x value is 1, we will get only one pair. So other than this, no matter what value y you substitute in this formula, you will not get. Okay, let's substitute x equal to 1 in this formula. So what happens? 1 power y is greater than y power 1. So what is this? 1 power anything is 1 is greater than y. So here 1 is greater than y. So when this condition will be true? This condition will be true if and only if you substitute 0 in place of y. Other than 0, if you substitute any number like 2, 3, 4, 5, 6, this condition is false. So by taking this, one thing I can tell, whenever x equal to 1, only y equal to 0 forms a pair such that x power y is greater than y power x. So that means one thing I can tell, whenever x equal to 1, number of zeros in BRR forms pair. So basically what is that pair? That pair is 1 comma 0. Apart from 1 comma 0, no other combination of x comma y satisfies this condition, x power y is greater than y power x. So let's take one more condition, 3. So we have seen for x equal to 0 and x equal to 1, right? So now whenever x is greater than 1, then y equal to 0 comma y equal to 1 also forms a pair such that x power y is greater than y power x. So okay, let's take one condition. Whenever x equal to 6 and y equal to 0, x equal to 6 and y equal to 1. So what happens here? So 6 power 0 is greater than 0 power 6. 6 power 1 is greater than 1 power 6. So obviously anything power 0 is 1 is greater than 0 power anything is 0. Here 6 is greater than 1. So this is condition, this is true, this is true. See, whenever x is greater than 1, so y values which are greater than x is okay. But whenever x is greater than 1, y equal to 0 and y equal to 1 also forms the pair. So by this, one thing I can tell, whenever x is greater than 1, number of zeros comma ones in BRR forms pair. So this is basically three main important exceptions. So apart from that, only one small exceptions, that is, those are 2 comma 3, 2 comma 4, 3 comma 2. So these three are some special pairs, important special pairs. Even though see 2 cube 3 square, 2 power 4 is greater than 4 square, 3 square is greater than 2 cube. So in this case, if you see here, 8 is greater than 9. No, see here x is greater than 1 and y is greater than x, but still this condition is false. Here also the same thing, 16 is greater than 16. Here also the same thing, x is greater than 1 and y is greater than x, but this condition is false. Here the third case is different. Even though here x is greater than 1 and y is less than x, but still this condition is true. 9 is greater than 8. So we just need to minus these two pairs and add this pair, that's it. So basically, to solve this problem, we have taken one mathematical observation, that is, whenever y is greater than x, obviously x power y is greater than y power x, but with 4 exceptions. In that, basically the exceptions are 0 comma 1 only. We need to handle it separately. Whenever x equal to 0, there is no pair, and whenever x equal to 1, only 1 comma 0 is the pair. So whenever x equal to 3, the normal condition is okay, but even though my y equal to 0 comma 1 or less than x, but forms the pair, so that we need to handle separately. And these three are special cases, 2 comma 3, 3 comma 4 and 3 comma 2. In these cases also the same thing. If first two cases doesn't satisfy and the third case satisfies, so we need to minus this and add that. So very simple. So basically how we will solve this problem is, so we will be following a two-pointer approach. There are two arrays, right? ERR and BRR. So basically, let's assume this is an x and one pointer is pointing to two pointers I comma j are pointing to the starting of the array. Now, what is the mathematical observation which we have seen? Whenever y is greater than x, x power y is greater than y power x. So basically what we wanted this many number of pairs. We need to pair so that x power y is greater than y power x. Now, what we will do to solve this problem is, first we will sort the arrays. So these two are sorted. Sorted in the sense it is in the ascending order. So from here to here it is ascending order. So first we will iterate through the x. That means ARR. So we will iterate in the ARR and every time we will find a y so that y is greater than my x. So this is our condition, right? So we will find a y in the BRR that satisfies this condition, y is greater than x. Up to then we will iterate my j pointer. So first I will fix my I. After that I will iterate my j pointer. So this BRR is sorted. That means it will be small, big. It is small number to big number. So my j pointer will be traversing to the right side and it will find a y so that my y value is greater than the x value. Now from here at this particular frame, I can tell this x comma y is a pair. And one more thing also I can tell. This is sorted array, BRR is sorted with the x value. If y satisfies, obviously the right side elements of the y are greater than y. So example, this is y1, this is y2. So obviously y2 is greater than y1. Then what I can tell, x comma y2 will also form the pair and x comma y3 will also form the pair and so on. So all the elements right side to the y will form a pair with the x. Why? Because all the elements right to this pointer pointing to the j are greater than the x. That means every everything will be forming a pair. So how to get this many number of pairs? Okay, let's take an example. This array of ARR length is n and this BRR array length is m. So how to get this many number of pairs? So in this length I need to just minus the j, that's it. So every time what I can tell, for every x value, find a jth position so that my jth position value y is greater than ith position x. So after finding that, one thing I can tell, what all the elements right side to the y is greater than the y1. So everything will form a pair. That means how to get that number of pairs? We can get by just subtracting my m with j. That's it. So in these two arrays, every time I will take 2 pointers. For every pointer, I will iterate this I, this j, and I will get to a place where x is greater than y. So in this case, what I can assure that all the elements right side to my y are greater than y. So every element will form a pair with x. So what I can tell? I can tell that if this count is m and this index is j, so for this particular element x, there are m minus j pairs forming. And one more thing, see, after this x, this is also sorted. So this is also sorted. So after that, I will increment my pointer, and there is x2 example here. So for x2 also, this all elements left side to the y will not form the pair. Why? Because x2 is greater than my x1. Then I can't find any value which is left side that should be greater than my x2. Why? Because both are in the sorted order. So what I can tell, the element y which I am finding, obviously it will be right side. So left side I can ignore. So basically in two arrays, I will iterate from here to here. So this will be just going to right side. There is no point of iterating left side. Why? Because while finding the greater number, these both are sorted arrays. So for this x1, I have find a greater number here. For x2, there is no possible value of y which is greater than on the left side. Obviously it will be on the right side. So this is the process which we follow to find the number of pairs. So let's code this. Of a number of pairs in Python. So here, as we discussed, to solve this problem, the both arrays should be sorted, right? So first I will sort them. X dot sort, y dot sort. For that I need to return the pairs, right? So for that I need to store the values. So answer equal to 0. In answer I will be storing the number of pairs, and after that I will take a capital N and I will store the length of y array, second array. In that only I will iterate, right? So for that length I will calculate. Now so here if we see our exceptions, so whenever x equal to 1, number of zeros in BRR forms the pair, right? So here also number of zeros and ones in BRR will forms the pair. So every time to calculate number of zeros and ones and twos, it is tough, right? So that's why I predefinedly I am calculating number of zeros, ones and twos and threes and fours in y, and I will store in the variable. It is so that I can use in the code in future. It is very simple for calculation. So C0, number of zeros in y, so y dot count of 0. So similar fashion, I will just initialize some more variables which are C0, C1, C2, C3, C4. C0, C1, C2, C3 and C4. Count of 1, 2, 3 and 4. So I'm just in C0, C1, C2, C3, C4 variables, I'm just counting the number of zeros and ones and twos and threes and fours are in the y array. That's it, very simple. And after that I need to by keeping x position static, I will iterate in the y array and I will find a y so that my y is greater than x, right? So for that, first I will initialize my y pointer j equal to 0. After that I will iterate through the x, right? So for x in capital X array, so here first what I will do is, here first I will handle the exceptions. After that it is easy for me to calculate the original formula. So what is the first exception? If x equal to 0. So whenever x equal to 0, we don't have any pairs, right? So just continue. X double equal to 0. Yeah. So we don't have any pairs, right? So just continue. So what is the next exception? If my x double equal to 1. So whenever my x equal to 1, so what is the condition here? Number of zeros in BRR, that is second array. So how to get the number of zeros? Here predefinedly we have calculated, right? C0. So I just need to add that to my answer, C0. That's it. So after that, x equal to 0 and 1 completed. So what will be the else case? Obviously my else case will be x greater than 1. So whenever my x is greater than 1, so what I told, number of zeros and ones in BRR will form a pair. So where are number of zeros and ones? Here I am predefinedly calculated. So I just need to add them. Answer plus equal to number of C zeros plus C1. That's it. Now, so 3 exceptions are handled. What is the fourth exception? Fourth exception is whenever x equal to 2 and x equal to 2, y equal to 3 and 4 will not form the pair. So I just need to minus them. That's it, right? So one condition I will write, if my x double equal to 2 minus y equal to 3 and y equal to 4, right? Here I have predefinedly 3 comma 4 I have calculated. So I need to just answer minus equal to C3 comma, sorry, C3 and C4. That's it. I just need to minus C3 and C4 in the number of pairs. That's it. Now what is the next case? Whenever my x equal to 3, if my x equal to 3. So then what I need to do here, even though my condition is false, it satisfies, right? So here I need to add. So answer plus equal to y equal to 2 here. So number of 2's, C2. Very simple. So here we have handled all the exceptions. So here comes the actual thing. So up to where this while loop will iterate. So my j pointer up to when it is goes to the end. And one more thing. What condition I need to get? My small y, if it is smaller than or equal to small x. Obviously I need to increment. So j plus equal to 1. So this while loop will be iterating and getting a point of small y where my small y is greater than small x. Very simple. So after getting there, what I need to do? I need to just add n minus j number of pairs. That's it, right? So whenever my pointer will go and reach here, so these many number of pairs I need to add. That's it. So answer plus equal to n minus j. That's it. So here we have handled all the cases. So here first I will sort the array and I will initialize the answer. This n is for just to calculate the length, and these are for just in the code counting of zeros and ones and twos and threes and fours, just for the encode purpose. Initialize the pointer and see iterating in the x every time. I will hand the exceptions. So what exceptions I have? Whenever x equal to 0, no pair will be forming. So that's why continue. Whenever x equal to 1, number of zeros in y, right? So add number of zeros. Whenever x is greater than 1 in the else case, so every case number of zeros and ones will form the pair. That's why I have added. So what is the fourth case? Fourth case is like whenever x equal to 2, 3 comma 4 doesn't form a pair. That's why I'm minusing. Whenever x equal to 3, even though the condition satisfies, it will, even though condition is not satisfied, it will form a pair. So that's why I'm adding. Now here comes the actual formula, which is I need to find a small y so that my small y is greater than small x. So for that I use this condition to iterate that pointer to that place, and after that I am just adding n minus j number of pairs. That's it. So this obviously will give me the correct answer. I need to just return the answer. Return answer. Yeah, submit. Yeah, correct answer. If you really like the video, please like and share and subscribe and click on the bell icon. Thank you.